I have created a header and program file called PSYDH9state that contains a context and a state object. The state object is then further subclassed into concrete states that are used in my game. These will be shown off throughout the program. My context object holds a reference to the current state and is able to swap between the states following a function call from the current state itself. It acts as a way to call each function that the engine would call in the states. The context is also able to properly delete any memory allocated to the state before swapping. My engine subclass, PSYDH9engine, maintains a reference to PSYDH9 context for easy function call. I have then created a class, PSYDH9filterpoints, which allows the users to zoom in and out. This is implemented on the main menu screen to mimic the Star Wars opening crawl seen at the start of the video. This works to set the zoom level for the rest of the game, as other states do not further edit these values. As you can see, the player is able to enter their name into the display. This name is later stored in a file and is displayed to the user if they make it onto the high scores list, one of the 5 highest scores in the game. The string is only 3 characters long because the game was designed after 80s style arcade games. Later on, this string is to be decoded by the program when it's loaded onto the high score screen. The saving and loading of the data, while not advanced, does follow a set structure which is displayed on the screen now. Once you enter the game, you can see displayable objects. There are the player object, in the form of Luke Skywalker, as well as the shield generator he must defend and the stormtroopers he is defending it from. The blaster bolts are also displayable objects. Each of these objects acts differently to each other. Luke and the stormtrooper are both subclasses of PSYDH9 character, the subclass which adds the functionality of movement as well as attacking. PSYDH9 projectile was initially implemented so I could have different types of blaster fire, but then I found out I had run out of time to implement this. The class added a check for collision detection with both the player and the shield generator. Speaking of collision detection, my state has a method to handle this collision, so the game can tell when attack and block buttons are pressed whether or not to perform the relevant action, as seen in the video. This collision detection uses a static function to check the rectangles that the object is drawn around to see if there is an overlap. This collision works on both blaster bolts and stormtroopers. Throughout the game, the stormtroopers appear pseudo-randomly, and this happens after the state has started to run. The object will be destroyed once it is attacked and cannot be interacted with, as it is removed from the object array in the displayable image container. Similarly, the stormtroopers' projectiles are also dynamically and pseudo-randomly created and destroyed over the runtime. I do not recreate the object array and instead use the provided functions to manipulate the context and add and remove objects from the array at will. Each stormtrooper has a very basic range of artificial intelligence. It makes decisions of where to move based on the position of the player character. If the enemy is on the same Y level as the player, it will move out of the way. Similarly, if the enemy notices it had moved past the player, its speed will increase and is more likely to decide to shoot the target. This chance increases the further away from the player the enemy is. The reason for this is to simulate a fear factor in the troopers, as the closer Luke is, the more scared they are. I've also, as you can see, used a technique of parallax scrolling to make my game feel more realistic. When the player moves Luke to one side of the screen, the background scrolls in the opposite direction to a maximum of 50 pixels by translating the image drawn by the number of pixels. This method utilizes copying the background buffer with an offset value to move the image from inside of the state. This manipulates the drawing region of the image. This is also controlled independently of the player character by the keyboard. Both my win and loss states have an animated background using 5 individual frames, each stored in their own surface, to play an animation behind the success and failure images. The animation is of a Star Wars starship going to hyperspace from a first-person perspective. To make this player sprites, I use a sprite sheet using variables to track the frame draws per second and have assigned the animation a number of frames per site. Using a calculation, the character object decides where on the sprite sheet it must draw from. I've also, as you can see, created and used a subclass of Tile Manager to draw the images as tiles to represent the health of Luke Skywalker. Other things that my program adds includes a level system, which increases the difficulty of the game using a linear equation. My program also has sound effects for when the characters of Luke are created and blaster fire occurs.
I'm not afraid.
I hope you've enjoyed my demonstration video.